What is cytogenetics and what does it tell us about someone's AML?
So when I talk about DNA mutations, that's in the actual coding of the A, C's, T's, and G's in the DNA itself, the actual letters on the page of the instruction manual. But all that DNA is organized into large pieces of genetic material called chromosomes. And that's when cells divide, a condensed version of all that genetic material. And so when a cell divides, all of the chromosomes align at the center of the cell and then will make copies of themselves and separate into opposite sides of the cell and turn into two cells with equal separation of chromosomes into either side. Sometimes there is a mistake or a break or something called a translocation where you don't have all of the chromosomes going to both sides, and so a chromosome can be lost, a chromosome could be gained, and a chromosome could break apart with the heads and tails switching from one chromosome to another. All of these things are what we call cytogenetics. They're basically the level of DNA that we can see with our eyes in a dividing cell. And so this is something that's been around for nearly half a century and really was pioneered by some amazing leukemia physician scientists like Janet Rowley, who was the first person to identify what's called the Philadelphia chromosome, where a part of chromosome 9 and a part of chromosome 22 switched heads and tails and now creates this abnormal gene called BCR-ABL that tells that cell to grow and not to mature into a particular type of white blood cell. And so the cytogenetics are another important piece of information that tell us whether this patient is likely to respond to chemotherapy, likely to go into remission, or if this is really likely to be a challenging type of leukemia to treat.